The present problem is of GATE 2007. It's of 2 marks. It's also based on the network theorems. We'll read out the problem. For the circuit shown in the figure, the Thevenin's voltage and resistance looking into XYR. There are 4 options here. We have to find in this circuit the Thevenin resistance and the voltage at the terminals XY. What we observe here, there is a voltage source which is a dependent voltage source. Because this is current I, the value of the voltage source is 2I. Since the value indicated here is 2I, it's misleading, and it looks that there is a current source. But you look at the symbol of this voltage source and notice that it says not a current source but it's a voltage source having a value of 2I. So 2I is the current in this part of the network. Now Thevenin's voltage is open circuit voltage Vxy. Thevenin voltage basically is open circuit voltage at the terminals Vxy. So Vth is equal to Vxy, and we can write the KCL at this node. So this is Vthevenin. So Vthevenin minus 2I. Vthevenin is the voltage at this point, minus 2I of the voltage source. Vthevenin minus 2I upon 1. This is a 1 ohm resistance, so this is the current flowing. Now Vthevenin over 1 ohm here, this is the current flowing I, and then again Vthevenin over 2 ohms here, because of this 2 ohm resistor, this is equals to 2. So this current is going into the node, so its direction is different. So if you solve this equation, YVTH, Thevenin's voltage minus 4I is equal to 4. So you get one equation of this kind, and I we can determine from this, that is Vthevenin divided by 1 ohm resistor. So we can eliminate the value of I here in these equations, and we get the value of Vthevenin equals to 4 volts. So this is one part which we have determined. Now we can determine the second part here for the network. We can find the Thevenin's resistance, short circuit current through so that we could determine, you see here there are 2 circuits which are equivalent to each other. This is Vthevenin and R Thevenin. This is Thevenin's equivalent. This is circuit is the Norton's equivalent. So one could use any one depending upon the problem, but for the circuit here, which is having both dependent and independent sources, finding the short circuit current turns out to be simpler. So we'll determine the value of R Thevenin from the Norton's equivalent. So we can know that the value of the resistance, Thevenin resistance, could be Vthevenin divided by ISC. Vthevenin divided by ISC. Since Vthevenin divided by ISC short circuit current is Vthevenin divided by RTH, so it is same. So if we can find the ISC, that short circuit current, then we can very easily find the value for RTH. Now we can just get an idea. So here short circuit, we do short circuit at XY, it's a shorted. So basically there is voltage is 0 here, since they are shorted. Vxy is 0. Vxy 0 means if I see in this branch IR2 is 0 here, that is I is 0. Since resistance is not 0, so I is 0. So I is 0, so we get a short circuit current of ISC is equal to 2 amperes. Since this is 2 amperes, this entire current will flow into this network. This current is 0, so it's 2 amperes. Now the R Thevenin is equal to V Thevenin by ISC. V Thevenin is already known to me. ISC is 2 amperes, so it comes to be 2 ohms. So we have determined that the option is R Thevenin is 2 ohms and V Thevenin is 4 volts. So this is option D in this problem. So this is a problem considering dependent and independent voltage and current sources. So you can do the problem while finding the Thevenin resistance using the Norton's equivalent, or you can do using the Thevenin's equivalent. Whichever turns out to be simpler, you can apply the corresponding method.